Alright gang, hitting chapter 5. Using pre-built methods. We've done just a little bit of this. We've used a scanner, right? We've used like next int or next double in order to read something in. We haven't used very many other. I believe we've probably used math.pow, right? As a matter of fact, we will be talking about the math class. There are the string methods, and these concepts are pretty dang important, so we will spend a lot of time on them. The wrapper classes for primitive types, we're probably not going to talk too much about those. Yeah, we'll mention them, of course. So, Java's built-in classes are stored in its class library, which is known as the Application Programming Interface. You can find the documentation for that online. Although, I think we're using Java 8, but it doesn't change that much from version to version. But if you Googled up Java 8 Application Programming Interface, you'd get it. So the API classes are not part of the core Java language. Right? The core language are the if statements and the class statements and the loops and the ability to create variables and to do math and stuff like that. Instead, they are classes that have been added to the base, in order to give Java additional capabilities that it does not otherwise have, such as the ability to read from the keyboard with the scanner class. So if we see java.util, that is the package, and scanner is the class that's inside the package. How do we know it's a class? It begins with an uppercase letter. So what is a package? It's a group of classes. So far we've just been creating one class at a time, but we could create a whole group of classes if we wanted to. The java.util package contains quite a few general purpose utility classes. But the one we need for now is the scanner class. So some classes are so important that the Java compiler automatically imports them for you. Those are made part of the java.lang package. For example, the math class. Let's see if we can find out what else is in there. If we do import java.lang.asterisk, up here, import java.lang.asterisk. As a matter of fact, if we did java.lang. Here we get a list of all the classes that are part of java.lang. And so these classes are available to us without even adding an import statement. We don't have to add that import statement. It's done automatically. Right? There's an error class, an exception class, a float class, an integer class. Notice that these classes all begin with uppercase letters. The math class. All sorts of things. Let's get rid of that because we don't need it. So the asterisk is called a wildcard because it brings in all of the classes in that package, not just one. And it doesn't slow anything down to do that. Don't worry that if you include .asterisk, it's going to somehow slow the program down because you included too many packages. So to use an API class, you don't know the internals, or you don't have to. You just need to know how to interface with it. It's like a car. I think maybe the car is the best example of a user interface that I can think of for this example, right? You know how to use a car, right? You sit down in the seat, you turn the key, you start the car, you look at the speedometer, you turn the wheel, you press on the gas, you press on the brake, right? That's the simplest kind of car, right? And pretty much, you can drive 99% of the cars out there. Now the speedometer may be on a digital screen nowadays, right? Might be all fancy and stuff like that, but those cars still have, gas pedals and brake pedals. Maybe there's some kind of fob that starts the car rather than a key, but it's the same general idea. So you know how to interface with a car. All we need to know how to use a class is its interface. We need to know that if you're going to use a scanner, you can call next line or next int or next double and so on. And you just need to know what they do. You don't need to know how it pulls in input from the keyboard. You just need to know that it does. So to use a method, you need to know what type of arguments you pass to it. And in this case, none of these take any arguments, but the math class certainly does. And what type of value it returns. So the standard way to show that information is to show the method's source code heading. What does that mean? For example, public int next int. This is part of the scanner class, and it's telling us that there's no arguments, that it returns an int, and that it's declared as public so that any code that wants to can use that method. So the return type means that when we call nextInt, we're going to get an integer back so that we can do something with it. If it was not going to return anything back, and there are methods that do that, they don't need to return anything. Like what about printing? Does printing need to return anything? If you call, system.out.printf, does it return anything? No, so it's probably declared as void. So void means it doesn't return anything. Otherwise, it's going to be a return type, like double or int, something like that. So all the methods in the API library are public, because otherwise there wouldn't be any need, right? Your code couldn't access them. So why put them in the library if your code can't access them? It's like having books in a library, but they're stored in the basement. Nobody has a key. We wouldn't want that. So the math class is useful. It's got an absolute value method, right? And the absolute value can take an integer, and it returns an integer. So if you pass in the absolute value of 5, it'll return 5, because that's what absolute value means. It just means drop the negative sign. If you pass in negative 10, it's going to return 10, right? It's going to drop the negative sign. There's a version of ABS, of absolute value, that takes a double and returns a double. And here's one called max, which takes two values and returns a larger of them. And there's a version of it that does integers, and there's a version of it that does doubles. So, for example, if int x is equal to 10, int y is equal to 3, int z is equal to math dot max x comma y, right? Then what is z going to equal? Well, what is larger? Oh, come on. Where's my semicolon? The 10 or the 3? Well, the 10 is obviously larger than the 3. So if we printed z out, we would see that it was a 3. Or we could just set a breakpoint there and find out, right? But anyways, let's print it out. System.out.println, quote, z equals, end quote, plus z. Just to prove to ourselves that I'm not lying. Alrighty, and in fact, z is 10. There's another method called min, right? Minimum. If you've done Excel spreadsheet programming, you know these kind of functions, a minimum and the maximum of two numbers. There we go, right? And the minimum of 10 and 3 is 3, so the 3 gets stored into z. And what was the one they had just demonstrated besides max? Absolute value, right? So if we say x is equal to negative 20, and then we say z is equal to math with a capital M, because that's the name of the class, dot abs, parentheses x in parentheses, right? What's the absolute value of negative 20? It's just 20. So if I copy and paste that print statement, we're going to see that it's now 20, right? And there are all sorts of methods in the math class. As predicted, it printed out a 20. Let's just type math dot and see what we have here. Math dot, oh boy, a whole bunch of things. Ceil, which stands for ceiling, which means round up. So if something is 3.7, it'll be rounded to a 4. But if it's 3.0, it's not going to get rounded up, right? Because that's the whole number. And that's what ceiling means. And floor is the opposite, right? Floor means round down. So if something is 3.7, it'll round down to a 3. But if something was 3 all by itself, it'll still be a 3, of course. 3.999 would round down to 3. And is there a round function as well as a ceiling function and a floor function? Sure there is. All right. What else? You know, we've done max and min, and the POW, raise one power to the other. Random, generate a random number. There's other ways to generate random numbers. We probably won't be using this particular one. And here's round. You want to round, you know, a floating point number so that if it's 3.3, it'll round down, right? Standard rounding rules, but if it was 3.6, it would round up. Let's just declare a double now, right? Double D is equal to math.pow 3 to the power of 2, which is just 9, right? And we can print that out. System.out.println parentheses D equals in parentheses plus D. Right? See what that is. We know it's going to be 9. Probably be 9.0. See how it prints it out. I don't recall. Yeah, 9.0 because it's a floating point type. In this particular language, you can raise things to fractional values, like something to the power of 0.5. Now, it's just a math trick that raising something to the power of 0.5 is actually taking the square root of it. One of the reasons I'm not going to go into. But if we did this, D is equal to math.pow 100, 0.5. It takes a number 100 and raises it to the power of 0.5, which is the same as the square root. So if I printed D out, I would see that it was 10. Right? Just like that. How many more of these functions do we want to test out? I don't know. I've talked about ceiling and floor, right? But D is equal to math.ceil of 9.9. It's going to raise it to 10, right? I'm just going to copy and paste that. Because ceil means round up, no matter what, right? Now when I run it, I'm going to see that D is 10. Oh, well, it was already 10 from the 100 square root, but it is, right? Okay, make that slightly different. Let's make it 8.8, right? Or heck, let's make it 8.1. Right? It's still going to get rounded up because that's what ceil does. And so as predicted, 8.1 rounded up by the ceiling function is 9. How about if we take the floor of it? I'm just going to copy those two lines and change ceil to floor. Right? And so if you round down 8.1, it's just going to turn into 8.0. Right? Even if it was 8.99999, right, it's still going to round down to 8 because that's what floor means. How about the round function? Just going to paste that again and change floor to round. And so 8.1 would round down to 8, of course. But 8.6 rounds down, right? Because aren't the rules of rounding that anything 0.5 or greater rounds up? I believe that to be the case. Right, so that's 9. Well, let's find out. 8.5, see if you round up or down. Yep, to 9. So those are the rules. If it's greater or equal to 0.5, it rounds up. Standard rounding rules. You're familiar with those. All right, so we've seen a bunch of math functions, and there sure are a lot of them. I like that one, ULP. I have no idea what ULP does. Returns the size of an ULP of the argument. Unit in the last place. Okay, whatever. I'm not going to look it up. If you need to convert between degrees and radians, if you're a geometry fan, you can do that. Why do you need to do that? There are some functions like tangent and sine and cosine and stuff like that that actually want the degrees to be expressed in radians. And so if we have any problems that we want to do that I want to demonstrate involving sine or cosine or tangent, we'll probably be messing with radians. Otherwise, I don't think we will. I'm not expecting anybody to remember the difference between the two, although, you know, if you're a math major, I'm sure you know. or if you remember your high school math. Yeah, I think that's about it. I wonder what next down means. Returns a floating point value adjacent to f in the direction of negative infinity. What? All right, I'm going to ignore that. Anyways, you get the idea. You can begin to type the class name followed by a dot, and if it's part of the Java API, this little help screen comes up and tells you good information about it. You don't even have to go online to the web to find out. And it tells us what it takes as a variable, right? And what it returns. Next down takes a float, and it also returns a float. And I'm sure that there's a version of next down that also accepts a double, right, and returns a double. I would expect that to be the case. Yeah, right, 2 different versions of it. Whatever. Don't know what that means, but you can tell, right? And the minimum takes 2 variables. It can take 2 integers, and it would return an integer. So you need to know those things. Those are the user interface. Just like the gas pedal and the steering wheel and the brake pedal are the interface to your car. All right, I'm going to pause this and come back to it later. Picking up where we've left off. How do these wrapper classes, how does a math class work? From a technical standpoint, why are we able to use math.round, math.floor, math.ceiling without having to do this? You've seen how we had to create a scanner, right? We had to type that. We had to type all that before you finished typing that in. Anyways, we had to create a new scanner before we could use it, right? However, for the math class, we don't have to do that, right? We don't have to create a new scanner. We don't have to create a new math object. Instead, we just call these methods that are already part of the math class. That's because these are what are known as static methods or class methods. A class method is one where you do not have to create an object like we did here. You just use a class name. Here's how you create a static method. I'm just going to scroll up here and create a new class. Every class should go in its own file, but I'm not going to do that. And I'm just going to call it sample, right? And so I'm going to make a public int, times 2, right? Or triple, that's what I'm going to call it. And it takes a variable, it takes an argument that is of type int, and it returns 3 times that, right? That's all it needs to do. So if I want to call that, method, let's see if we can clear out some of the stuff here. All I have to do is something like this. Int result is equal to sample dot triple, and then pass in some kind of number. Right? And so what's the result going to be here? Well, I seem to have a result here, an error here. Non-static method. Well, I forgot to make this static, right? I was just bragging about static. There we go. Public static int. Right? That means you do not have to create an object from the sample class in order to access it. Notice you see that keyword here. Java does not have to create an object before it calls main. So it's real easy for it to call main and get things started. What if you have something that is not static? This is called an instance method. Public int quadruple. I'm just going to call it quad. Right? It's going to return 4 times x. Don't know why I put spaces here and not here. Okay. To use that one, I'm going to have to create an object from that class. I would have to do this in order to use that method. Sample SA equals new sample, right, like that. And then I could use it, right? Result is equal to SA dot quadruple, right? Just quad is what I called it. And so now result's going to equal 40, right? Because we're passing in 10 as our argument. 10 goes into the parameter variable there. We multiply it by 4 and we return it. Right? Here, when we called it, we had to use an object. We had to precede the name of the method in front of the dot with a variable that's representing an object that was created with the new keyword. Here we just used a class name. That's because this is a static method, right? Static method, otherwise known as a class method. This one is a non-static method, so it's an instance method, meaning you have to have an instance of the class in order to use it. An easy way to know the difference is if the thing before the period begins with a capital letter. Since classes are supposed to start with capital letters, this means it's probably a static method. If you did not have to create an object in order to access it, it's a static method. And that's easier to use, right? So if you don't need to create an object, why would you? Right? But we do have to for the scanner class. Wherever I stuck my scanner, did I delete it? Yeah, I probably did. But you have to create a scanner so that you can call nextInt or whatever on it. So that is not a static method. That is not a class method. NextInt is not a static method. Instead, it's an instant method. Hope that makes sense. So wrapper classes. Wrapper classes for primitive types. What is a primitive type? A primitive type is just a pure numeric value, right? Like int I is equal to 3. Int is a primitive type. Now in some languages, everything is an object, including ints and floats and doubles and things like that, but not in Java and not in C and C++. It's a primitive type, meaning it doesn't have any methods. I can't type II dot and get a list of methods for it. But what if you need to do something more complicated with an int? You need to convert it to a string, or you need to parse it from a string into an integer, or you need to find the maximum value that an integer can hold. Instead, we would use what's known as the wrapper class. Integer, how about WI for wrapper, right? Equals 3. Now we have an object that is of type integer with a capital I, the whole word, right? You can tell the difference. This is a wrapper class because it begins with an uppercase I. This begins with a lowercase I, so we know it's just a primitive type. So integer is a wrapper class, right? And why do you use wrapper classes? Because they have more abilities, right? We have already established that II doesn't have any methods or any properties attached to it. I can't type II dot and get a list of things I can do with it. It's just a pure number. I can do math with it and print it out and stuff like that, but check this out. If I type WI dot, I see a whole bunch of different things I can do. Whole bunch of different methods. ToString, convert it to a string. Whole bunch that I don't even know what they do, right? Get a float value out of it. Get a long value out of it. Get a double value out of it. I'm not totally sure why you need to do that because you can just use casting, to get that value out. But compare to. What does compare to? It returns 0 if they are equal, less than if one integer is less than the other, and greater than if the argument is greater than. So, for example, we could say, we already have one called result, right? Result is equal to WI dot compare this to 2, right? At this point, I messed that up. Let me type in dot and get the list of methods, right? Compare 2 with a capital T, right? And compare it to the number 2. So, result would equal, let's just add this as a comment. Result will be 0 if the numbers are equal, if the values are equal. Result will be, will be less than 0 if the argument is less than the value. Remember, the value passed to it is the argument. And result will be greater than 0 if argument is greater than the value. So why would you just not use if statements, and if something is equal to something else, or if something is less than something else, or if something is greater than else? I'm not really sure. But it's an example that this wrapper class, this object from this wrapper class, has additional powers. There's no way we could generate something that was equal to 0 or less than or greater than with a simple call like that if we were just talking about I. What if we want to convert it to a string? String S is equal to WI, because that's the wrapper, dot toString. There, now it has been converted to a string. Honestly, there's an easier way to do that, but it's kind of a little hack, right? You just say S is equal to empty string, pair of double quotes, concatenate the value of I to it, right? Like that. What if you did not want to create a wrapper in order to convert I to a string? Right. If I had to do this, if I had to do it as a two-step process, create an object from it and then call toString on it, nobody would ever do that. Everybody would always do this. And instead, we would do something like this. S is equal to integer. I'm going to use a method, a class method, toString, and I would pass in I. There we go. So these are the two ways, well, really three ways, but these are the two ways that you can convert int II to a string. And that works for doubles as well, right? I'm pretty sure that would, double DD, I hope we don't already have this variable, is equal to 3.3, or heck, m underscore, or math.py, semicolon, and you want to convert that to a string. S is equal to double dot toString, and then pass in that variable, right? If we printed S out, we'd see whatever it's equal to. System.out.println, parentheses quote, S equals, end quote, plus the value of S. And let's see. You gonna run for me? Why are you not letting me expand the window? Here it is. Oh, come on. Sorry about that. That was a little bit weird. Here's our string. All right. Ran it out to like 15 decimal places. That's how it was converted. Okay, so great. I could have converted it just like this, as we have already talked about. I could have just said S equals empty quote plus D. The results might be a little bit different. Let's see what the results are. I'm going to copy and paste that. Sure, it's giving me a lot of warnings. Probably variables that I never used. Okay, so now when I run it, the two different versions, did they present two different results? Wait, that was a value of I, wasn't it? Yeah, let's print out. No. Yeah, there we go. I should have made that DD to match math.py. So when we run it now, yeah, same thing. Okay, so that works just as well, right? That's certainly faster. No, it's not faster, but it's easier to type than that. And you could, argue that that was more correct somehow, because this is just relying on concatenation in order to build our string. Totally works though. How about if we wanted to find out the largest value that can be stored in a double? System.out.println parentheses double with a capital D because it's a wrapper class. Ooh, I'm not seeing it. Here it is. Max value, right? So when I go, this will show the max value, right? Max value of double equals, end quote, plus double dot max value. Again, this is an instance member because we're not having to precede it with the name of an object. It's got a capital D there, so we're preceding it with the name of the class. There we go, right? Very large number, exponent 308. In other words, 1 followed by 308 zeros is the largest value that can be stored in a double. Actually larger than that, right? 1.7. Anyways, that's how you get the maximum value. You want the minimum value? You could do that as well. Why don't I just copy that and change max value to min value? Oh no, did I make it too strong? There we go. All right. And the min value, right? Funny how it can get even more negative than it can get positive. What do I mean by that? Positive exponent only goes up to 308, but the negative exponent goes down to negative 324. Wonder why. I never noticed that before. Okay, so what wrapper classes do we have? We have double, we have integer. Is there one called byte? No suitable constructor for byte. But let's see. Byte dot. Yep, it's got things. So wrapper classes include. And what is byte? It's just something that's 8 bits long. Whereas an int is 32 bits long. A double is 64 bits long, as well as the type long. Anyways. So byte, integer, float, double. I'm going to put long over here next to integer because it is an integer type, right? There we go. I'm sure there are others, but those are the math versions, right? Let's find out how many other wrapper classes we have. Excuse me while Wi-Fi reestablishes its connection. Come on. There we go. Great. Boolean, short, character, long, float, double. All right. So the only ones I really kind of forgot was to do that one in character. Does character have a max value in it? Let's find out. I'm going to just copy this line again so I can paste it and change max value of a character is equal to character dot max value. Hope that exists. Ooh, they sure do have a lot of different options. Max value. Okay, let's find out what the max value of a character is. Alrighty. We would have to convert that into an integer in order to see what that really was. How would we do that? We could cast this to an int. We could say, please take this return value right here and convert it into an int. Then we find out the integer value of it. So the maximum value of a character is that. Now that tells me that a character is 2 bytes wide because the maximum value of 16 bits is 65535. Like if you remember the name of the Nintendo 64, it's because it could access 2 byte data sets to just pick the number of characters and the resolution and things like that. So, you know, it had considerably better resolution than your old Nintendo or your Genesis 16-bit devices. No, wait, that's not right. Anyways, gonna go with that. Let's give some homework over this. One more thing we need to do is to go from a number. Wait, we've gone from a number to a string. Let's go from a string to a number. Like if we ask the user to type in a value and we want to convert it, right? So system.out.println, parentheses, enter a whole number, right? And now we're going to parse that and store it in some kind of result. Kind of run out of variable names. I don't even know what I've called things, right? So, but I'm just going to call this one int I1. Oh, that looks like IL, you know. N1 for number 1 is equal to integer dot parse int based on our string. Now we don't have anything good in our string yet. So we should ask the user to give us a piece of data. And in this case, we're going to store the input in a string before we convert it. Well, you know, we need a scanner. Scanner sc equals new scanner system.in. Then we can use it, right? Well, we have to add java.util.scanner to it. All right, right? And now that we've got our scanner, we can use it to read it in, right? Let's give it a better name than just S, which we've already used, right? So string, I don't know, S1 is equal to scanner sc.next, just like that, next. Not next int, dot next returns a string. And that's all we need. Let's do this, between 1 and 100. Enter a whole number between 1 and 100. There's a reason why I'm making that limit. That's just to make sure that we don't type in a value that's too large to fit into an integer. That's how you do it. If you wanted to convert that number to a double, right, or a short, or whatever, you could do short sh1 is equal to, but let's just call that n2, right? Because we have n1 up here. Short n2 is equal to short dot parse short parentheses s in parentheses, right? Now we've converted that string also to a short. We could do the same thing with double dot parse double and long dot parse long, right? And that should have been S for string, right? And long dot parse long. Kind of wish they just made it parse, right? Dot parse rather than have to repeat that type there. More typing, but whatever. Okay. So we have converted that number to 2 different variables, and if we use this one, we could do those things as long. So, what's our homework assignment going to be? Print the max value of the following wrapper classes: short, integer, long, float, double. Okay. That's about enough. Then ask the user for a number between 1 and 1,000 and convert it, parse it with the wrapper parse methods to the following types: short, int, long, float, double, and print those values out. Make sense? You're just going to print the max value. Heck, let's get the min value as well for each type. Make your output look kind of good rather than just print out a whole series of numbers. Let me know. So then we're going to print out the min value. All right, hope that makes sense. Given the examples up here, that should not be too difficult of an assignment, but if it is, please contact me. All righty, see you next lecture.